Hi, I am Babylin Omar and I will introduce to you one of the ideal gas law, the Charles law. But before that, for most people, the words ideal gas might conjure up the image of some kind of superfuel, perhaps a near inexhaustible kind that creates zero air pollution. Sadly, this is not what is meant by ideal gas law. Gas is everywhere. Actually, there is two types of gases, the ideal gas and the real gas. Ideal gas or perfect gas is the theoretical substance that helps establish the relationship of four gas variables: pressure, volume, temperature, and amount of gas. The particles in the gas are extremely small, so the gas does not occupy any spaces. The ideal gas is constant, random, and straight line motion. No forces between the particles of the gas. Particles only collide elastically with each other and with the walls of container. Real gas, in contrast, has real volume and the collision of the particles is not elastic because there are attractive forces between particles. As a result, the volume of real gas is much larger than of the ideal gas, and the pressure of real gas is lower than of ideal gas. All real gases tend to perform ideal gas behavior at low pressure and relatively high temperature. Moving on to the one of ideal gas law, which is a Charles law, also known as the law of volumes, is an experimental gas law which describes how gases tend to expand when heated. It was first published by French natural philosopher Joseph Louis Gay Lussac in 1802, although he credited the discovery to unpublished work from the 1780s by Jacques Charles, hence the name. This law applies generally to all gases and also to the vapors of volatile liquids if the temperature is more than a few degrees above the boiling point. Given the interest in hot air balloons at the time, it is certainly understandable why Gay Lussac, Charles, and other scientists around the globe were so interested in the relationship between volume, pressure, and temperature when it came to gases.
Day STIers, this is Ryan H. Ubon, and today we are going to talk about Charles' law. In a gas, its physical behavior is described by these four variables, namely pressure, volume, temperature, and amount, or also known as mole. In this video, we will have Charles' law, which is concerned in the relationship of volume and temperature. Charles' law was formulated by the famous scientist Jacques Charles less than 2 centuries after Boyle's law in 1800. This law described how gases will expand when heated. In his experiment, he prepared a test tube with trapped air under a small mercury plug. It was immersed in water bath with heating coil for heating and cooled with ice. Upon changing the temperature, the volume of the gas trapped in the test tube also changes. Having all the data, he then found out that volume and pressure follows this graph as shown. It can be seen in the graph that there is a dashed line portion because theoretically, when gas reach absolute zero temperature or negative 273.15 degrees Celsius, the gas occupies zero volume. But no one has even seen this phenomenon. The temperature unit is in Kelvin for SI unit, or when we write it in a mathematical terms, we have volume directly proportional to temperature. This relation can also be expressed as the volume over the temperature is equal to some constant. If we have a gas under two different conditions, we can write the formula as V sub 1 all over T sub 1 is equals to B sub 2 all over T sub 2. In the formula, we can see that under a certain condition of the gas, increasing the volume will result in increasing the temperature, or decreasing the volume will result to decreasing of temperature.
Good day, STIers. I am Rico Geplos, and I will discuss to you the Charles law formula. If pressure is constant, the volume of these gases and temperature will be directly proportional, meaning if we increase temperature, the volume will increase, and if we decrease temperature, the volume will decrease. This means of the gas of equation for Charles law is volume 1 over temperature 1 equals volume 2 over temperature 2. Don't forget that the pressure has to be constant.
Hi, I am Farhana Kunsa and I will show you one example of how to solve Charles' law. Example of Charles' law. Consider an 150-gram helium balloon. The balloon is fastened to a tarpaulin of a ship moving from Miami is 1.70 liter at the temperature 29 degrees Celsius. What will be the volume of the balloon at New York City if the temperature at New York City is 12 degrees Celsius? Assume the pressure remain 1 atm. Note: temperature must be in Kelvin from the equation work. You calculate Kelvin temperature by adding 273.15 to the Celsius temperature. The equation for Charles' law is V1 is equals to 1.70 liter, T1 is equals to 29 degrees Celsius, V2 is unknown, T2 is equals to 12 degrees Celsius. First, we convert the temperature in the Kelvin from the degree Celsius. T1 is equals to T1 plus 273.15. T1 is equals to 29 plus 273.15. So the total number of T1 is equals to 302.15 Kelvin. T2 is equals to T2 plus 273.15. T2 is equals to 12 plus 273.15. The total number of T2 is equals to 285.15 Kelvin. The initial volume is 1.70 liter. The final volume can be calculated from Charles' law. V1 over T1 is equals to V2 over T2. V2 is equals to T2 times V1 over T1. V2 is equals to 285.15 Kelvin times 1.70 liter over 302.15 Kelvin. So the total number of V2 is equals to 1.60 liter. Thus, the volume of the balloon at New York City is 1.60 liter. V1 is equals to 1.70 liter. T1 is equals to 29 degrees Celsius. V2 is equals to 1.60 liter. T2 is equals to 12 degrees Celsius.
Hi, this is Norol Dayanalan. Another example or problem solving for this is a 3.5 flexible containers holds a gas at 250 Kelvin. What will the new volume be if the temperature is increased to 400 Kelvin? So volume 1 here is 3.5 liters. Temperature 1 is 250 Kelvin. And our goal is to find volume 2. We need to calculate its value. The new temperature is 400 Kelvin. So all we got to do is to substitute this given value to the Charle's law equation and solve. So V1 is 3.5 liters. T1 is 250 Kelvin. We're gonna just rewrite the V2 and T2 is 400 Kelvin. The best thing you called to do this problem is cross multiply. So 3.5 times 400 is equal to 1,400 and 250 times V2. Now, the next thing that we need to do is divide both sides by 250. So bring down V2 because 250 are cancelled. And 1,400 divided by 250 is 5.6. Therefore, the new volume is 5.6 liters. As we increase the initial temperature of 250 Kelvin to 400 Kelvin. That is Charle's law work. Anytime you increase the temperature, the volume will increase also.
Hi, my name is Majida Ekaharudin and I'm here to conduct an experiment about how Charles' law works. Charles' law stated that temperature increase, the volume will be increased. that, here's the material. I have a bowl with cold water and bowl with hot water, a balloon, and a cold glass bottle that I put in the refrigerator for 1 hour. First step, put the balloon in a top of cold glass bottle. It is used to shell the top of the bottle. Next step, put the cold glass bottle in the bowl with hot water. Make sure that the water not too hot because it could melt the top of the balloon. Observe what will happen to the balloon. As you can see, the balloon is reflecting because of the temperature inside the bottle. The volume is increased. Next is transfer the glass bottle in the bowl with cold water. And observe what will happen to the balloon. And now, it is holder, the balloon should compress and those molecules will be moving in the slower rate so that balloon will start slow down. Put the bottle in refrigerator for 1 hour so that we can see what will happen to the balloon. After 1 hour, the air inside the bottle has cooled down. That's all. I hope you learned what I did.